Sign convention, Cartesian sign convention. All distances measured from pole. The distance measured in the direction of incident light is positive and opposite to it is negative. So the distance measured above the principal axis is positive and below the principal axis is negative. Here you see the situation. Here is a light source, source of light, and light is coming in this direction. This is a mirror. This is the polished part, and this is the reflecting part. And incident light is in this direction. So, and we have to measure all distances from this point. This point is called pole of the mirror. So in this direction will be positive and this direction will be opposite to the incident light direction will be negative, and above direction will be positive and below the line direction will be negative. In this case, because light is incidenting from this side, light is going in this direction, so the direction of light is considered as positive direction. So if we measure the distance, say from pole, then this will be the pole, then this direction will be positive and this direction will be negative, and upward direction will be positive and downward direction will be negative. This, but the convention is to take the above situation. Now paraxial ray, the ray incident on the mirror very near to the pole is called paraxial ray. If the ray is incidenting on the reflecting surface of mirror and it is very near to the pole, that is like this, and then such type of ray will be called paraxial ray. Now principal focus. Principal focus. Principal focus. This is a reflecting surface or a mirror, and this is the principal axis. This is the pole of the mirror. Now, if parallel ray coming parallel, this is the parallel ray. After stacking the mirror, it passes through a point, and that point is called focus, principal focus of the mirror. These all parallel ray converge at a point, and that converging point is called principal focus or focus of the mirror. Here, this is the situation for concave mirror, and this is the situation for convex mirror. That is, it converge or appear to converge at a point, then it will be called the focus of the mirror. In this case, this is the parallel ray, and after reflection, this reflected light is appear to coming from this point. In this case, this light is appears to coming from this point, so this point will be principal focus. Focal plane. The plane passing through the focus and perpendicular to the principal axis is called focal plane. We see this is a principal axis of the mirror. This is mirror. In this case, this is a concave mirror, and if we draw a plane from this point perpendicular to the plane of paper like this plane, then this plane will be called focal plane, and definition is given like this. This is the focal plane as shown in the figure. Relation between radius of curvature and focal length of the mirror. Now, here consider two situations. One is for concave mirror and one is for convex mirror. Here we see that AV light is incident light, and after stacking the mirror at this point, it reflected in the same medium and goes through this point focus. And in this case, AV is this is the incident light. After stacking at point P, it goes like in this direction after reflection. So in this case, after reflection, light passes through this point, and in this case, the light after reflection appears to pass coming from this point, and so this point will be called focus in both cases. Now this is the principal pole of the mirror, okay, and this is the principal axis. In this case, this is the principal axis, and this is the center of curvature. Here C is the center of curvature, and we know that from this distance C to P distance will be called R, radius of curvature, and this distance will be called radius of curvature. In this case, PC will be radius of curvature. In this case, FT will be focal length, and in this case, PF will be focal length. Here, AB ray is paraaxial. From law of reflection at B, I equals to R. That is, if we draw a perpendicular from this point, this will go through the center of curvature by the law of geometry, because it is a circular part or as part of a sphere. So it must, normal must go from the center. So this line will go through the center, and we know that the angle made by incident ray to the normal is angle of incidence. So it will be angle of incidence, and this will be, because this is the reflected ray, so this angle will be angle of reflection, and by the law of reflection I must be equal to R. So here it is given from the law of reflection at P I equals to R. So in the triangle CBF, we have I equals to R. Therefore, the triangle CBF is a isosceles triangle, because this angle is equal to this angle, and now this angle is equal to this angle, because this line is parallel. So this angle will be equal to this angle. Now in triangle, this both angles are equal. So this will be a isosceles triangle. Therefore, the angle is isosceles, hence CF will be equal to the CB or FB. CF will be equal to FB in both cases. As the ray AB is paraxial, so point B is very close to P. Hence, we can write FB equivalent to FP, equation 2. So, from 1 and 2, CF equals to FP equals to F. Now, CP equals to CF plus FP equals to F plus F. This implies R equals to F or F equals to R by 2. So, this is the relation between the radius of curvature and the focal length of the mirror. Now ray diagram for image formation in a spherical mirror. Here we will learn the rules for making ray diagram, showing ray diagram in a spherical mirror. The first rule is ray coming parallel to the principal axis will pass through or appear to come from focus after reflection. Here see the ray is coming parallel to the this is the principal axis. Here this is the principal axis. So ray is coming incidenting, and after reflection it passes through focus. So all the ray coming parallel to the principal axis will pass through focus and appears to coming from focus. In this case, passing through focus. In this case, because after reflection it is going in this direction, so it appears to coming from focus. This is the case of concave mirror, and this is the case of convex mirror. Hello. Now ray diagram for image formation in a spherical mirror. First rule, ray coming parallel to the principal axis will pass through or appears to come from focus after reflection. We have discussed this situation. Second, ray coming along the focus or appear to coming along the focus will become parallel to principal axis after reflection. This is the situation. Here ray is coming along the focus, so after reflection it will become parallel. In this case, ray appears to coming towards the focus, so after reflection from this point will be parallel to the principal axis. Third, ray coming along center of curvature or appears to coming along center of curvature retraces its path after reflection. Here this is the situation. Here ray is coming or passing through the center of curvature, or so it after reflection it retraces its path, that is returned to its path, and in this case it appears to going to the center of curvature, so after reflection it will get back on the same path. Fourth, a ray incident at pole of any angle will be reflected with same angle. This is true for any point on the mirror to follow the second law of reflection. Here a ray is incident at pole, so if this angle is I, so this angle must be R. So the ray will be reflected with same angle and I will be equal to R. This is rule to follow the law of reflection, and in this case here this is the incident ray and this is the reflected ray, and I will be equal to R. Now let's discuss about the image formation. Image formation in concave mirror. Image formation in concave mirror. First case, when object is at infinity, that is object is placed at infinite distance, then image will be at focus and image will be real, inverted, very smaller in size, and magnification will be very less than 1. Second case, this object is between infinity and center of curvature. If the object, this is the object, and it is between infinity and center of curvature. This is the center of curvature, and it is just beyond the center of curvature. In this case, the image is between C and F. This will be real, inverted, small in size, and magnification will be very less than 1. You can to make a image, we should take two incident ray, one parallel to the axis and one going through the center of curvature. Then this ray after reflection gets back from the focus, and this ray retraces this part and the cutting point makes the image. Third, if the object is at